So let me say good evening to everyone, and we're just doing a little review. And so this is a problem that was posted in the discussions. This is order of operations. I don't know how far you got with that, but we did talk about the grouping symbols. So order of operations, please excuse my dear Aunt Sally. And so this fraction bar is a grouping symbol, okay? So that's a grouping symbol. So that means that we need to do the top first, do the bottom, and then we divide. So when we look at the top, we talked about these two negatives coming together and they cancel. So that's the top. Now let's look at the bottom. In the bottom, this is a 9, and this 9 is in front of this parenthesis, and it's connected through multiplication, okay? But now we can't multiply until we see what this is. And so this is 3 subtract 4 subtract 7. And so to help you, this is 3 plus negative 4 plus negative 7. Okay? So the top is 19 and the bottom is 9 times. So 3 plus negative 4 is negative 1 plus negative 7 is negative 8. We know that a positive times a negative is a negative. So this is negative 72. Now we never leave the negative in the denominator. So we can put it out here, or we can put it in the numerator. And we can leave it just like this because it doesn't divide out evenly. So this is negative 19 over 72, or the opposite of 19/72. Discussion about anything that we did here.
Would you reduce that even further, that fraction?
It doesn't reduce evenly because 19 is a prime number, so I would just leave it like it is.
Well, 4 goes into 19, or rather, well, okay. I was going to say 19 goes into 72 4 times, but that would be, you can't divide from the numerator into the denominator.
Yeah, I mean, you can do that, but 19, check that again. See if you can divide that again. If it were 18, it might would work, but it doesn't work with 19.
Yeah.
Because 19 is prime. So if you divide 19, if you think it's 4, let's check it. So that's 36 and carry my 3. So that would give us 76. So that wouldn't work.
Yeah, I'm thinking, yeah, I'm thinking this.
But you're on the right track. If you could, you would take it down some more, but we can't.
Right.
Okay. All right. Let's do this one.
Professor,
Yes.
yeah, question. In the blue parentheses, is 3 minus 4 minus 7.
Mm-hmm.
So, can you explain the difference? Maybe I'm a little late. Can you explain the difference in why do we put parentheses, make it -4, and then add it rather than just
Okay.
doing
Yeah.
straight
Okay.
subtraction?
Yeah. Well, the definition of subtraction is add the opposite, and so I changed it to addition so that you could see it better. But the
Right.
definition of subtraction says, so the definition of subtraction, add the opposite of the number being subtracted. So let's go back to our problem. So 4 is being subtracted, and it's a positive 4. Okay? So the definition of subtraction is add, which is your plus. The opposite of the number being subtracted, a positive 4 is being subtracted. The opposite of a positive 4 is a negative 4. All right, here, this is a positive 7 that's being subtracted. So the definition of subtraction says add the opposite of the number being subtracted. So therefore, I get a negative 7. Now let's go back to this one. All right, a negative 8 is being subtracted. So that's plus because subtraction says add the opposite of the number being subtracted, and the number being subtracted is a negative 8, so that's a positive 8. So we did the same thing here that we're doing here. And the reason I changed it all to addition is so that you can see the numbers and get it correct, because this is a negative 4 and that's a negative 7, so that you can end up getting a negative 8 and not get it incorrect. Now, if you don't need to change it, that's fine, but I just changed it so that you can see it. Because
Thank you,
clearly, if you
Professor.
have 3 and you subtract 4, you're going to go in the hole there. So I would, I always like to change it so that you can see what is going on. Okay, further questions about this? Other questions? Does that answer your question, Angel?
Yes, it does. Thank you,
Okay.
Professor.
All right, so let's go to this problem. So with this problem, let's just go through and see what operations we have. We have a subtraction, exponents, subtraction. Now here we have a parenthesis with division and an exponent. But we do know that parentheses come first and then exponents. We do know that, okay? So we know that subtraction is a lower level operation, so therefore it would be last, okay? So we know we need to do parenthesis, and then we need to do the exponents. And you probably might want to write these out so that you can follow and keep up with yourself. So we need to do the parentheses, we need to do the exponents, and then we do subtraction. All right, so I start over here, and I say 4 subtract, and I'm going to just rewrite this for now, and I'm going to do this parenthesis, which is negative 4, and then squared. So I have the parenthesis taken care of. Now I need to do my exponents, okay? So these are my exponents. So that's 4 subtract 9. Now, you want to be careful. See, this negative can't go through here. Why? Because it's parenthesis and we got an exponent out there. If we did not have this exponent, you could do that, but it cannot go through the parenthesis. So you have to say minus, and negative 4 squared is negative 4 times negative 4, which is 16. Okay? And so this is subtraction. And I'm going to put a little plus there and a plus there. So this is 4 plus negative 9 plus negative 16. And so this gives me negative 5 plus negative 16, which is negative 21. Discussion about this one.
I got a question on, you had mentioned something about subtracting and the exponent. If the exponent wasn't there, you can actually do something. Can you go
Yeah.
back to that? The black
Yeah,
marking? Yes.
right. Okay, so that's 4 minus 3. 4 minus 3 squared minus 4. What's that? Right here. Okay, this exponent is with this, so I can't take this through there. But if I had something like this, if it was just a regular parenthesis, we could take this through there. And that would be 4 minus 3 squared plus 4. But because I have an exponent here, I have to do this exponent first. Does that help?
Yes. Yeah, I think I got it.
All right, well, let's look at it again. Well, let's look at it like this. Or this is a subtraction symbol. Subtraction does not take precedence over exponents. Remember? So I can't take this through there because subtraction is a lower level operation. I have to do exponents before I can do any subtraction. Because actually what I did here was subtraction. I just took the shortcut. This is subtraction. I am subtracting a negative 4. The definition of subtraction says add, which is
Adding
what
the
I'm doing,
opposite.
the opposite of the number being subtracted. The number being subtracted is negative 4. So the opposite of negative 4 is a positive 4. The thing, we're just recognizing that when two negatives come together, they cancel. But the reason they cancel is add the opposite of the number being subtracted. That's why they cancel. The opposite of the number being subtracted is a positive 4. So this is why this is plus 4. Now, over here, exponents take precedence over these subtraction symbols, so I can't do that. I have to do this exponent first. Questions about that?
Nope, got it.
Okay. All right, let's review solving an equation. So solve this equation, and then we will continue with equations and looking at word problems. So when we solve an equation, we said that we want to simplify. And we said that simplify, remove, let me go get my, let me go back. So these are our guidelines. So simplify says remove the parentheses, remove fractions and decimals. Let me make this a little bigger. Okay. All right, so we want to remove the parentheses. We do have a parenthesis, so let's do that. In order to remove the parenthesis, we need to use what we call the distributive property, meaning that we're going to distribute everything to this parenthesis. So I rewrite the left. And I use my distributive property, -2 times v, and then -2 times 4, that's going to be a -8. So I have removed the parentheses. Now it says remove fractions and decimals if you have any. We don't have any fractions or decimals. So we complete that and that. Now it says add like terms on the same side. This is the left side. And this is the right side. We don't have any like terms on the same side. So we have finished simplifying. Now the next step is to isolate. It says the variables and numbers are different, therefore they must be on different sides of the equation. To accomplish this, you will be adding or subtracting, not multiplying. So let's focus then on the variables. Let's put the variables on the left. And then we'll put the numbers on the right. But we're going to do one thing at a time, okay? All right, so let's focus on the variables. So let's find them. That's 4v and -2v, okay? Now, our goal is to get them on the left-hand side, okay? So this is the left-hand side of the equation, so this is okay. This is not okay. It is on the wrong side, okay? And so I need to get that -2v off of the right side. I can't just take it and move it. I have to undo it, and when I undo it, I always have to practice the golden rule. Because this equation we talked about last week is like a balanced scale. The scale is balanced. And anytime I do something to it, I have to keep it balanced. I have to do what I do to one side, I have to do to the other. Okay? So because I want to get this -2v off, I have to undo that. So that's a negative, so I need to do a +2v. Because this is a scale, what I do to one side, I have to do to the other side. Okay? Now it's still balanced. Once I do this, I need to see what I have. 4v and 2v is 6v. This is a plus, 16, and then equal. Now these cancel, and then this is -8. Okay? All right, now I need to put the numbers on the right-hand side, okay? All right, so let's take a look at this. This is the left side. Now, this is a number, so it is not okay. This is okay, okay? So we're going to put the numbers on the right because we agreed. It doesn't matter which side. We just agree this is what we're going to do to keep our work straight, okay? Because this is not okay. I have to get it off that side. I can't just pick it up and move it. So I have to undo that. That's a +16. To undo that, I need to say -16. Because my equation is like a scale, what I do to one side, I have to do to the other. And after I perform the operation, I need to clean it up and see what I have. So I'll go back to the left, that's 6v. This cancels, this is equal, and then this is -24. So as you see, the variables are on one side and the numbers are on the other side. Now, I'm not finished because I want to know what 1v is equal to. This tells me that 6v is equal to that. So the final step is to divide. You're going to divide by the coefficient of your variable if it is not 1, okay? All right, so because this coefficient is not 1, I'm going to divide both sides by 6. And then v equals -4. Once you solve your equation, then you can go back and check it. All right, discussion about this. Any questions? Well, it's going to be, let me get my timer. So let me see if I can let you try one. So try this one and we'll take 2 minutes. And once you get it, you can put your answer in the chat. Okay, I see one answer. Okay. Okay, that's by Q. So let's see what we got. All right, so we do have some parentheses, so we need to remove those parentheses. And we're going to do that using the distributive property. So we're going to distribute 5 times v and 5 times 3. So 5v plus 15 equals -4v plus 42. Okay? We don't have any fractions or decimals. We don't have any like terms on the same side. So we finished simplifying. So now we want to isolate. We're going to stick with the script, variables on left, and numbers on the right. So let's focus on the variables, okay? So this is the left side, so this is okay, and then this is not okay. And so what is not okay has to be moved, and we just can't pick it up. We have to undo it. So this is a -4v. So to undo that, I add 4v. Because this is a scale, I have to keep it balanced. I need to do it to both sides. Once I do it, I need to clean it up and see what I have. 5v plus 4v, 9v plus 15 equals, this cancels, and then 42. So I have the variables on the left. Now I need to get the numbers on the right, okay? So this is 15, it's on the left, so it is not okay. And this is okay, okay? So I need to get this 15 off of the left side. Again, I can't just pick it up and move it. I have to undo it. So this is a plus. I say minus 15 on the left because it's a balanced scale. What I do to one side, I have to do to the other. I say minus 15 on the right. Then I clean it up. This is 9v. This cancels. This is equal. And then this is 27. The final step is to divide. We need to divide by the coefficient of the variable we're solving for. We want to know what 1v is equal to, not 9 of those. So I divide by that coefficient, 9 on the left, keep it balanced, 9 on the right, and v equals 3. Okay? So everyone has that answer. Discussion about this. Any questions about solving your equation? Okay. All right, let's go to word problems. And so these are keywords. Plus means add, more than, increased by. Plus, sum, subtraction, subtract, minus, less, less than, diminish by, difference, decreased by. X times, multiplied by, product of, twice. Division, quotient, divided by, divide, per, ratio. Now, I want to talk about less versus less than. If I say 4 less 5, this is 4 minus 5. If I say 4 less than 5, this is 5 minus 4. Okay, so less and less than would be different. Questions about this? Okay. All right, so let's translate. It says translate the phrase into an algebraic expression. Now, to translate these, you read it. So you want to read it about 3 times. And what that does, it gives you a chance to get familiar with the words and think about it. So that's it. Let's read this to yourself about 3 times, and then we'll talk about it. And so let's go back to the words here. So here are the words over here, and then this is what we're supposed to be working with. All right, so the word quotient means to divide. So let's dissect this. So if you have quotient, you have to have at least 2 things. And so we have of, which is your preposition here. It tells you what to get the quotient of. The quotient of what? C and 3. So you can write it like this. C divided by 3. Or you can do C over 3. That's the quotient of C and 3. Questions about that? All right, let's take a look at this one. It says translate 53 53 less than twice Greg's score. So these are really good problems because you just go through and you dissect. So this is, we talked about less than, here it is right here, less than. So that number goes at the end, is that right? We know that twice means 2 times. Greg's score, we don't know, so we can do an S. So 53 less than twice Greg's score would be 2S minus 53. Discussion about that. Any questions about how we arrived at this? Okay, let's try this one. So now, okay, if you notice here, we don't have, this is just division. And here, this is just subtraction. We do not see, they call this an expression, okay? Now it says, translate this sentence into an equation. So now we're going to an equation, and let's see why, okay? Now, what does the word product mean?
Multiply.
Multiply. And when you multiply, you have to have at least 2 things. The of tells you what you're going to use. 6 in Carlos' age. So the product of 6 in Carlos' age, we don't know Carlos' age, so I'm going to use an A for that. Okay? Now, is means equal. So I have 6A equals 90. When I say use C, I'll use C. Okay? 6C equals 90. Okay? And if we wanted to find the answer, we would divide by 6, and we get 15. All right, you do this one. Let's see. This says Laura baked 45 cookies. Her family ate M of them. How many cookies are left? Okay, she has 45. And the family ate M of them. How many are left? Test your knowledge with that. So I have 5, and someone takes away, or 8, or whatever. So 8 is the same thing as what? Take away? So 45 take away M would be, how many would be left? So let's see. So if they ate 10, then 35. 45 minus 10, 35. So let's check. So what you can do, once you write your expression, then you can test it out with numbers. Any questions about that? Everybody okay with this? Do we need to go back with any of the expressions or solve it an equation or anything like that? Okay, so let's go to fractions. But we got some preliminary work to do, okay? So before we do any operation with fractions, we need to build a foundation. So we need to talk about our numbers. So an even number is a number that ends in 0, 2, 4, 6, and 8. So an odd number is a number that is not even. So that's 1, 3, 5, 7, 9, 11, 13. Any questions about an even number or an odd number? Everybody okay with that? All right, let's talk about some divisibility rules. Now, you already know about 2. A number is divisible by 2 if it is even. What is an even number? A number that ends in 0, 2, 4, 6, and 8. A number is divisible by 3 if the sum of the digits is divisible by 3. Here's an example. 423. If I add the digits in 423, we get 4 plus 2 plus 3, which is 9. Since 9 is divisible by 3, 423 is divisible by 3. So let me go back through this again. A quick way to determine if 3 will go into 423 is to add up the digits in 423. The digits in 423 are 4, 2, and 3. When I say 4 plus 2 plus 3, I get 9. 3 divides 9, so therefore 3 divides 423. So just in case you don't believe that, let's test it. So 3 would divide 4 one time. 1 times 3 is 3. 1, subtract. 3 would divide 12 4 times. 4 times 3 is 12. And 3 divides 3 one time. 1 times 3 is 3. So 3 goes into 423 141 times. Okay? All right, 4. A number is divisible by 4 if 4 divides the last 2 digits. So let's take 7, 8, and 9. 4 would not divide 8 and 9, which are the last 2 digits. Therefore, 4 does not divide 7, 8, and 9. 9, 24. The last 2 digits are 2, 4. This is 24. Because 4 divides 24, the last 2 digits, therefore 4 divides 9, 24. Divide that out for me. So 4 divided 9 2 times. 2 times 4 is 8. 1. Bring down the 2. 4 divides 12 3 times. 3 times 4 is 12. 4 divides 4 1 time. 1 times 4 is 4. Okay. All right, 5. A number is divisible by 5 if it ends in 5 or 0. Okay, you already knew that, right? So these numbers are divisible by 5. These numbers are divisible by 5 because they end in 0 or 5. All right, so 6. A number is divisible by 6 if 2 divides it and if 3 divides it, okay? So if it's even and then if it's divisible by 3, that should make sense. So if it's even, that means 2 divides it, and then if 3 divides it, 3 times 2 gives you 6. So that's how you can tell if a number is divisible by 6. If 2 divides it and if 3 divides it. And then we have divisibility by 9. The sum of the digits are divisible by 9. And then we have 10 if it ends in 0. So let me go back and look at these. So the easy way to do this is to kind of group them. 2 is an easy one to do. A number is divisible by 2 if it's even, okay? 3, a number is divisible by 3 if the sum of the digits is divisible by 3. A number is divisible by 9 if the sum of the digits is divisible by 9. Remember, here that is right here. A number is divisible by 9 if the sum of the digits is divisible by 9. Okay? So 3 and 9 have that divisibility rule. So we got 2, we got 3. Let's do 5. Let me go back. A number, if a number ends in 0, 5, and then 10. If you know 2, 3, 5, and 10, you should be okay. Okay? We did 4. A number is divisible by 4 if 4 goes into the last 2 digits. A number is divisible by 6 if it's even and 3 divides it. And then we went to 9, and then we went to 10. Okay? So I think if you can do 2, 3, 5, and 10, you should be okay. Because basically, we're going to be trying to reduce numbers. So that's what we're going to do. So let's take a review here. A number is divisible by 2, a number is divisible by 3, a number is divisible by 4, a number is divisible by 5, a number is divisible by 6, a number is divisible by 9, and then a number is divisible by 10. Knowing these 2, 3, 5, and 10, you can be able to reduce any kind of fraction that you have, okay? All right, the next topic we want to talk, have you ever heard of the word a prime number? Have you ever heard of that word before? A prime number. Okay, so a whole number greater than 1 that has only 2 factors, 1 and itself. So a prime number is a whole number greater than 1 that has only 2 factors, 1 and itself. So a factor is something that's being multiplied. That's what the word factor means. If you see the word factor, it means something that's being multiplied. And here are the whole numbers: 0, 1, 2, 3, 4. And these 3 dots means it keeps on going in this pattern, different by 1. So it says a whole number greater than 1 that has only 2 factors, 1 and itself. So let's see what kind of numbers we're talking about. Okay? So here is a chart of 100 numbers, okay? And we're going to go through and we're going to find prime numbers, okay? All right, so let me give you a chance. We'll just go up to 60. So if you can just write these numbers up to 60, and then we'll talk about them. And if you write 10 of them across like this, it's going to be easy for you, okay? So just go up to 60, and we're going to find some prime numbers. Are we ready? Okay, so the first thing I want you to do is to cross out the number 1, because we're trying to do prime numbers. Now remember, a prime number can only have two factors, 1 and itself. Okay? So the first prime you have is 2. Because 2 has only two factors, 1 and the number 2. Okay? Now, I want you to go through and cross out all the numbers divisible by 2. Remember, 2 is an even number, so we're going to go through and cross out all of the even numbers, and what you find is like every second one. So we're going to cross out all the numbers divisible by 2. Now, why are we crossing out all the numbers divisible by 2? Because these, we want only the prime numbers. If this number is divisible by 2, it's not going to be prime because a number is always divisible by 1 in itself. So if it's divisible by 2, it has more than two factors. A prime number can only have two factors. Okay? All right, so this is why we're crossing them out, because we want only the prime factors. And we're just going up to 60. Okay? All right. The next prime number is 3 because 3 has only two factors too. So that's 1 and 3. Someone just make a list here. All right, now I need to cross out all the numbers divisible by 3. Some of them are already crossed out. So all the numbers divisible by 3. So all I have to do is say 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay? Now, why did I cross those out? Because they cannot be prime because they have more than two factors. The next prime factor is 5. Okay? All right, so you know the drill. We need to cross out all the numbers divisible by 5. Okay? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? All right, the next prime number is 7. So I need to cross out all the numbers divisible by 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. We got that one. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Okay, we got that. Okay. Now, the next prime number is 11. We need to cross out all the numbers divisible by 11. Okay? Now, here is 11. I might can go down here. Do you see this diagonal like this? I might could do this. Let's see if that's going to work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That is correct. Okay? And we just go on to 60, so that row. Okay? All right, the next prime number is 13. Okay? And we cross out every 13th one. Okay? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the numbers we have left are prime. So 13 is left, 17 is left, 19 is left, 23, 29. Stephen, remember the problem we had before, and we had a 19. See, 19 is a prime number.
Yes, I thought I just knew my division was wrong, but yes.
Okay, 31 is prime. 37 is prime. 41 is prime. 43 is prime. 47, 53, 59. Oh, we just stopping here. Sorry. All right, so these are the prime numbers up to 60. And what this will help you to do is help you as you work with your fractions to see these prime numbers. Now, we didn't go past 60, but these are plenty prime numbers to work with. So you got 2, 3, 5, 7, 11, 13, 17, 19, 23. If you just know those, you're in good shape, okay? 29 is prime, 31 is prime, 37, 41, 43, 47, 53, and 59. Okay? All right, any questions about that? Looking at your prime numbers. Okay? All right, so let's talk about a fraction. What is a fraction? A fraction is part of a whole. What are the parts of a fraction? You have the top, that's called the numerator, and the bottom is called the denominator, and you also have the fraction bar. The numerator tells us how many parts we have. The denominator tells us the total number of parts. So let's test our knowledge. It says, what fractional part of algebra are A's? Okay? What fractional part of algebra are A's? So algebra would be the whole. Okay? The denominator is the whole. So we got 1, 2, 3, 4, 5, 6, 7 letters. And how many A's are in this word algebra?
2.
How many?
2.
2. So the fractional part would be 2/7. 2 letters out of 7 letters, because 7 would be the whole, and then 2 would be the part. Okay? All right, a proper fraction. The numerator is less than the denominator. So a proper fraction, the numerator is less than the denominator. 2/7, 3/11, 4/5. These would be proper fractions. Now, an improper fraction, the numerator is equal to, greater than the denominator. Equal to or greater than 11/11, 12/5, 13/7, 8/3. See, the numerator here is equal to, and here is greater than. That's an improper fraction. And then we have a mixed number. Mixed number is a whole number and a fraction. So 1/2, 3 1/5. This is the whole, and that's the fraction. Okay. All right, so we know a fraction is part of a whole. We know the numerator is the top, the denominator is the bottom. We got the fraction bar. We know about a proper fraction, improper fraction, and a mixed number. So we want to find the least common multiple of 4 and 6. Now, what does that mean? We want the smallest number that 4 and 6 will divide evenly. The smallest number that 4 and 6 will divide evenly. So how do we do that? Well, method 1 is take 4 and keep adding 4s to it. 4, 8, 12, 16. Take 6 and keep adding 6 to it. 6, 12, 18, 24. And then we're going to find the smallest number that's in common. Okay? The smallest number that's in common. And so the least common multiple would be 12. The smallest number that 4 and 6 would divide. 4 divides 12. 6 divides 12. Okay? Let me stop and see if there is a question about finding the least common multiple. Now, where are we headed with this? We're headed finding the least common denominator. That's where we're headed. Okay? Now, this is method 1 using multiples. And I have a method 2. And I can stay on, but you know, it is 9 o'clock, and I don't want to hold you up because you might have another class. So tell me what your preference is. You want to stay for a few more minutes, or we'll just come back next week?
You know, I'm fine. You can stay. That's my choice.
Okay. All right. Those of you who need to leave, you can do that, and I will have the recording. Okay. All right. So this is method 1. Finding the least common multiple, just doing the multiple way. The other way is what I like to call the LCD soup. And what we do, we factor the numbers into primes and dump them into the soup, and then we go from there. So let me show you how this works. So the numbers are 4 and 6, and I call this the LCD soup. 4 and 6. So I take the number 4, and this is why we use those prime numbers. So let me just write my primes. 2, 3, 5, 7, 11, 13, 17. That's about what I need. Okay. So I take the number 4, and I look at my primes and see what primes will divide it. 2 will. 2 will go into 4 2 times. 2 will go into 2 1 time. When you get 1, you stop. So 4 equals 2 times 2. The other number was 6. You do the same thing. You take the smallest prime that divides it is 2. 2 will go into 6 3 times. 3 will go into 3 1 time, and you stop. So 6 equals 2 times 3. So I do my soup, draw my circle, and I go to the first number, and I dump all of this into the soup, 2 times 2. Okay? Now keep in mind, I'm making a soup, and I don't want it too much salt or pepper or whatever in it. So if I already have an ingredient, I don't put it in there. So let's go to 6. 6 needs 1 2. Look at my soup, I got 2 2s, so I don't need any more 2s. 6 needs a 3. I look at my soup, I do not have a 3, so I need to put a 3 in there. Okay? All right. So this is going to be my LCD, 2 times 2 times 3, which gives me 12. Let me go back through this again. So the other way to find the LCD, or the least common multiple, is to use the LCD soup. To use the LCD soup, you have to use prime numbers and division. So we went through and found the prime numbers. These probably be sufficient for the numbers we're going to work with. You take your number and you take the smallest prime or a prime that would divide it. 2 divides 4 2 times. 2 are going to 2 one time. When you get 1, you stop. So 4 is 2 times 2. We go to 6. Get the prime that divides 6. 2 are going to 6 3 times. 3 are going to 3 one time. Stop right here. 6 is 2 times 3. Now we're ready to make our soup. We take the very first number and dump all that into the soup. 2 times 2. All right, we go to 6. 6 needs a 2. I look at my soup, have plenty of 2's. As a matter of fact, I have 2 2's. I only need 1 for this 6, so I don't need to dump anything in. But 6 needs a 3, and I do not have a 3 in my soup, so I have to put a 3 there. So 2 times 2 times 3 gives me 12. So that's using the LCD soup. All right, let's find the least common multiple of 18 and 30. Now, you might like the multiple way better, it's faster, and that's fine. So these are the multiples of 18. How did I get this? I take 18 and keep adding 18 to it. 18 plus 18 is 36. 36 plus 18 is 54. 54 plus 18 is 72. 72 plus 18 is 90. 90 plus 18 is 108. 30. 30 plus 30 is 60. 60 plus 30 is 90. I see then that 90 would be my LCM. Now, if you use the LCD soup, you do have to use prime numbers. And you probably might feel, well, you know, this is just a little bit too much work. I don't want to do that. And so using this is the multiple method. And it works. Okay, or you could use the LCD soup. Using the LCD soup, again, you do have to use prime numbers for this. So you have to put your primes up here. Okay, but keep in mind that for the most part, these numbers here, let me do this one so that you, because this is different. So I will do 18. 2 into 18 is 9. I can't use 2, I'll use 3, and then use 3 again. So 18 equals 2 times 3. I don't know why I keep doing that. 2 times 3 times 3. All right, let's use 90. 2 into 90, 45. 5 into 45, 9. 3 into 9, 3. 3 into 3, 1. So 90 equals 2 times 5 times 3 times 3. 18 equals 2 times 3 times 3. Now I'm going to do my LCD soup. And since I did 18 first, I'm going to dump it in first because I want to show you something. So I'm going to dump 18 into my soup. I've dumped that in. Now let's go to 90. 90 needs a 2. I have a 2. 90 needs a 5. I don't have a 5. 90 needs 2 3s. I got 2 3s. So I don't dump anything in there. It needs 2 3s. I have 2 3s. It needs 1 2. I have a 2. It needs a 5. I don't have a 5. So let's see what we have. 2 times 3 is 6 times 3 times 5. 6 times 3 is 18 times 5. And the LCD is 90. Okay? All right, so now we have moved from the least common multiple, and now we are to the LCD because that's where we were trying to go in the beginning. We want to find the least common denominator, which is the same thing as we did the least common multiple, okay? So we want the smallest number that 20 and 8 will divide. So I'm using the multiple method here. I list 20 and I list 8, and I get the multiples of 20. 20 add 20, 40 add 20, I get 60. 8 add 8, 16 add 8, 24 add 8, 32 add 8, 40. And then I want the smallest number. So the least common denominator is 40. Okay. All right. So we have found the least common denominator. Now we want to change this is an improper fraction. And we want to change it to a mixed number. To do that, we divide 5 into 16. 5 will go into 16. 3 times 5 is 15. Subtract, we get 1. Now, if we were using whole numbers, we would say remainder. But with fractions, we take this 1 and we put it over that number. So this is 3 1/5. So 16/5 is equal to 3 1/5. All right, let's reverse ourselves. We want to take this mixed number and we want to write it as an improper fraction. So how do we do that? We say 9 times 8 plus 1. So 9 times 8 is 72 plus 1 gives me 73. So this is 73/9. Okay? So this is interchanging mixed numbers and improper fractions. Let me let you try one. So change 11 1/2 to improper. So change that to an improper fraction. What do you get?
Sorry, 0.3.
Okay, so 2 times 11 is 22 plus 1 is 23. So that's 23 halves. All right, let's change 45/13 to a mixed number. 45/13.
Three and 6/13.
3 and how much?
3 and 6/13.
All right, so let's test it. So 13 will go into 45 3 times. 3 times 13 is 39. Subtract 6 13ths. Okay. All right, so now we want to add these fractions. And in order to add these fractions, you need a common denominator. Okay. It's best to get the least common denominator so that you don't have so much reducing to do. So a trick that you probably want to pay attention to is to look at your numbers and you see that they do have something in common, but that's fine. We want the least common denominator, and we do the multiple method. We probably already know this one, but we'll go through it. 6, 12, 18, 24. 9, 18, 27. We want the smallest number that they have in common, which is 18. So we come over here, we say 5 1/6. 3 and 2/9. Write your whole. Put your this is your least common denominator, 18. 6 will divide 18 3 times. 3 times 1 is 3. 9 to go into 18 2 times. 2 times 2 is 4. 3 plus 4 is 7 18ths. 5 plus 3 is 8. Now, this is where your prime numbers come in handy because 7 is a prime number, okay? So you can't reduce this unless 7 is going to divide 18. 7 cannot divide 18, so therefore this is already reduced. So you see how your prime numbers can help you know that you can't reduce your number. Questions about that? All right, let's do this one. We all probably know the least common denominator for this, and what is it?
12.
You can use 12. You can have some reducing to do, though. So let's do it. 3, 3, 6, 9, 6. So 3, 6, and then 6 is 6. So we could actually use 6, right?
Yeah.
3 are going to 6 2 times. 2 times 1 is 2. 6 are going to 6 1 time. 1 times 1 is 1. 2 plus 1 gives me 3. 6. 5 plus 4 gives me 9. So now we want to reduce, okay? We know that 3 will go into 6. And so 3 are going to 3 1 time. 3 are going to 6 2 times. So this is 9.5. Discussion about that. All right, do that one. That's straightforward. These already have a common denominator. So what's the answer?
5/8.
5/8. Yeah.
Can I reduce this?
No.
Why?
No.
Why can't I reduce it?
You don't have a number they'll multiply into either or divide into either numerator or denominator.
Right. See, 5 is prime. Excuse me. And 5 cannot divide 8. Okay. All right, let's do one last one. Now here we have negatives. So this is negative 1/4. Subtract 2/7. So this will help. Negative 1/4, excuse me, plus negative 2/7. We need to find a common denominator. So let's do that. So remember, we come over here and we got all the multiples of 4. 4, 8, 12, 16, 20, 24, 28, 32, 36. Let's write all the multiples of 7. 7, 14, 21, 28, 35, 42. Okay, I see something. 28 and 28. Do you see that?
Yes.
So now we need to change each one of these to 28. 7 to go into 28 how many times?
4.
4. And 4 times a negative, that's negative. 4 going to 28 how many times?
7.
7. 7 times negative 1 is negative 7. So negative 7 plus negative 8 is negative 15 28. Now let's see if we can reduce, okay? And this is where we go back to our divisibility rules. So 3 and 5 would divide 15, but 3 and 5 would not divide 28. So you would let it stay negative 15/28. Discussion about that. So those divisibility rules come in handy, especially when you're trying to reduce your fraction down. And I'll just keep my prime numbers and stuff available to see if I can do any reducing. We know how to do this. What is the answer to this one?
It's 6/12.
6/12
Or 1/2.
or 1/2. Very good. Oh, let's do this one, and I think this one would take us out for tonight. All right, so this is negative 8 1/9, and this is 3 2/3. Now, we can do this several ways, 2 ways. We'll do the first way first. We need a common denominator. What is it?
9.
9. So that's 9 to go into 9 one time. 1 times 1 is 1. 3 will go into 9 3 times. 3 times 2 is 6. What do we make of this? What do we do here?
You're gonna be -5.
Because see, this is negative and this is positive. And so we're working with sign numbers. And so when we work with sign numbers, we found that we forget about the sign until the end. So we forget about the sign until the end and we just subtract. But I can't subtract. So what do I do? Okay, let me show you what you can do. Now, students do different things. This is just like having money and you need some change. And the money that we're dealing with ninths. Okay, so I'm dealing with ninths. I only have 1 of this, but I need to take away 6. Okay, so what I do then, since I'm dealing with ninths, I have to get a whole. Okay, so I take a whole from the 8, that leaves 7. Now, the whole that I take from the 8, I have to always change it to this denominator. Whatever it is, I have to change that whole to that. So that's going to be 9/9. Okay? I already had 1/9. So the whole I changed to 9/9. I already had 1/9. That gives me 10/9. And then I just bring this over. Now I have enough to subtract. So 10 subtract 6 is going to give me 4/9. 7 subtract 3 is going to give me 4. So the answer is -4 4/9. Okay. Now some students don't like that. They prefer this. So we have 8 1/9, 3 6/9. Now, this is going to give you more work, but that's your choice. They like to change these. Once you get the common denominator, they like to change it to improper fractions. So 9 times 8 is 72, plus 1 is 73. 3 times 9 is 27, plus 6 is 33. So then 73 minus 33 gives us what? 40/9. And then you're going to have to change this. So 9 to go into 40, 4 times 9 is 36. And you have 4 left over. So you get 4 4/9. So it's your choice whether you want to get change. This is what I call the change method. So you're going to get change here. Or you use improper fractions. Okay. Any questions about that?
No.
Any questions about getting change or using the improper fractions?
I think the improper fractions is easier.
Okay. Yeah, students do like the improper fractions. But you do have to have more reducing. See, we didn't have to reduce over here. So you just decide what you like. Okay?
Yes, ma'am.
All right, I think we get into, I can do that next week, but this is good enough for you to go back and think about. So I'm gonna stop the recorder, and I thank